This is a video that's going to help you with your distributive property target test. The directions for the distributive property target test, at least the top half of the test, are this. For the following problems, draw a picture to show that each are equivalent expressions. So the two expressions for number 1 are 3 times 2x plus 3 and 6x plus 9. And I'm supposed to show that those are equivalent expressions. And I'm going to show them by drawing pictures of algebra tiles. So I have written this on a separate sheet of paper because I'm going to need a little bit more room to do this. It's 3 times 2x plus 3, and I have to show that that's equivalent to 6x plus 9. So with algebra tiles, what this means, on the left-hand side, it means that I have 3 2x plus 3's. Well, what that looks like, that's an x tile, and that's a 1 tile. What I have to show is I have 2x plus 3. So 2x right there plus 3, 1, 2, 3. Okay? That's 1 2x plus 3. I have to show if I have 3 of those 2x plus 3's, that would be equivalent to 6x plus 9. So what I'll do is I'll just bring out another 2x plus 3. There's my 2x plus 1, 2, 3. There's a second 2x plus 3, but I have 3 2x plus 3's because the number right here says I need 3 2x plus 3's. So I'll bring out a third 2x plus 3. And this is my third 2x plus 3. So if I group the algebra tiles like this, I can clearly see that I have 3 2x plus 3's. Here's one 2x plus 3. Here's a second 2x plus 3. And here's my third 2x plus 3. So I have a total of 3 of those 2x plus 3's. What I need to show is that's the same thing as 6x plus 9. The way I'm going to do that is separate my x's and my 1's. So let's move all of my 1's over here. There's those 3. And then let's move my x's over here. So what I have a total, as I separate them this way, it's very easy to see that those 3 2x plus 3's are the exact same thing as 6x plus 9. Okay? And what you need to do on the first problems is draw the pictures to show that they're equivalent. You have to draw a picture to show that 3 2x plus 3's is the same as 6x plus 9. So let's go back to our paper and let's go ahead and show that. So let's go back to our test paper and show that. So if I'm going to draw 3 2x plus 3's, these are both x's and they're positive, so I'm going to kind of shade them in a little bit. There's 2 x's. Plus 3. And you can see that that's 1 2x plus 3. But I have to draw 3 of them. So let's draw 2 more. And I just kind of shade them in a little bit. The reason I'm shading them in is to show that they're positive. Okay? If they weren't shaded in, that would mean that they're negative. But I'm going to shade them in just to show that they're positive. So I'm just shading them in very lightly to show that they're a positive 2x plus 3. So I have 2. Now I have to draw a third 2x plus 3. And here's my third one. Here's my 2x plus 1, 2, 3. So there's the drawing of my 3 2x plus 3's. Here's 1 2x plus 3. Here's a second 2x plus 3. And here's a third 2x plus 3. So total, I have a total of 3 2x plus 3's. Now what I need to do on the other side is group them differently to show that that's the same thing as 6x plus 9. So over here, I'll draw the 9 to start off with. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'll shade them in kind of lightly. And as you see that there's my 9. What I've done is I've moved this, this, and this over there and made my 9. So I'm showing that that's the 9. And now I'll move my x's over there too. So I have a total of 6 x's. So if I draw my x's all out, there's 3, 4, 5, 6. So I just shade them to show that they're positive, not negative. So I just kind of shade them like that. And there is 6x plus 9. So I showed that 3 2x plus 3's, 3 2x plus 3's is equal to 6x plus 9. Now your job is right now is you're going to stop the tape and you're going to show that the bottom two problems here. So you're going to write on a piece of paper, and what you need to do is show that 4x plus 3's is the same as 4x plus 12, and then after you do that, you have to show that 3x plus 5's is equal to 6x plus 10. So go ahead and do that right now, and then we'll take a look at it in a little bit. So I'm going to pause the recording, and you need to pause too and do those problems. Okay, if you finish 2 and 3, they should look something like this. So what I did on 2, I have 4x plus 3's, 1, 2, 3, 4, and I'm showing that that's equal to 4x, 1, 2, 3, 4x plus 12. And the second one, I have 2 3x plus 5's. There's 1, 1, 2, 3, 1, 2, 3, 4, 5. That's 1 3x plus 5. And here's a second 3x plus 5, 1x, 2x, 3x, and then 1, 2, 3, 4, 5. So clearly that's 2 3x plus 5's, and that's equal to 6x, 1, 2, 3, 4, 5, 6, 6x plus 10. So I kind of showed that with the expression. On the bottom half of these problems, you're not going to actually draw the algebra tiles out. All you have to do for this is just to tell me what the equivalent expression is. If the problem has parentheses, you're going to write it without parentheses. If the problem doesn't have parentheses, you're going to write it with parentheses. The operation, either addition or subtraction, always stays the same on these problems. So what I do on the first problem, what this means is I have 3 2x plus 7's, and I'm not going to draw them out. But what I'm going to do instead, when I use the distributive property, I take that 3 and I multiply it by everything inside the parentheses. So when I do that, I'm going to take the 3 times the 2x. Well, 3 times 2 is 6, so 3 times 2x will be 6x. Then I do the exact same thing. Since it's a plus sign in between here, I have to have plus in there. And then I take 3 times 7. 3 times 7 is going to be 21. So this becomes 6x plus 21. Now I'm going to do the exact same thing for any of the problems with parentheses, no matter if the number comes before or after the parentheses. What I'll do, I'm actually going to do probably about 5 of these for you. If I look at this next one, I have 7 times x. Well, that's kind of confusing because I don't know what x is. But when they just say 7 times x, that means 7 times 1x. So I'm going to take 7 times 1x, and that's just going to be 7x. Now in this case, there's a subtraction sign in between. So I have to put the subtraction sign there. And then what I have to do is I have to take 7 times 4. 7 times 4 is 28. So an equivalent expression for this is going to be 7x minus 28. The last one. Sometimes the number outside the parentheses comes after it. Now I still have to go from left to right inside the parentheses. I have to go from left to right inside the parentheses. But if it makes it easier for you, you can think or just pretend that the 7 is out there in front. And if it makes it easier to just draw the 7 like that, that's equivalent. And the reason that is because 4 times 3, I'll just write it over here, 4 times 3, that's the same thing as 3 times 4. So what I've done here is I've just changed. I had 3x minus 5 times 7 is the same thing as 7 times 3x minus 5. Okay? So now I can do it. It looks more like the one I just did, the ones I've done just above it. So what I'm going to do is I'm going to take 7 times 3, and that's going to be 21, but then there's 3x, so it's 21x. Since it's a subtraction sign, I'm going to put minus down, and then I'm going to do 7 times 5, which is 35. So it's 21x minus 35. Now, we have some other ones I'm going to show you. So sometimes they don't have parentheses. If they don't have parentheses, you have to write them with parentheses. So in this problem up here, on number 5, I'm going to do 5 and 6, and then I'm going to have you do the rest of these on this piece of paper, and then you're ready to take the test after you show them to me, Mr. Petterson. So if I'm trying to undistribute this, what I have to do is I have to find a common factor of 32 and 28. Now what I always do is I ask myself if the numbers are even. If the numbers are even, I know I can factor a 2 out of that problem. So in this case, they're both even. So I can factor the 2. And that 2, the number you can factor out, that's the number that goes outside the parentheses. I'm going to write my parentheses. Since it's addition, I'm going to write addition there. And then when I ask, 2 times what is 32x? Well, I know there's got to be an x in there because there's no x here. So I know there's got to be an x there. 2 times what is 32? And that's got to be 16. Okay, but then I can also look at the, now I have to look at the second part. I have to say 2 times what is 28. Now to do that, I basically can just divide 28 by 2. And I know that that's 14. That's one answer that I would accept for this. There's another number that I could factor out of 32 and 28 though. A bigger common factor of 32 and 28 is going to be 4. So I could have put 4 out there if I wanted to. And I'd still make the parentheses. So these are both correct answers. There's not one that's more correct than the other. But to do this, I say 4 times what is 32x? 4 times 8 is 32. So this has to be 8x. And then the next one, 4 times what is 28? Well, 4 times 7 is going to be 28, so that's got to be a 7. So that's how I factor that one. Similarly with the one below here, there are several common factors on number 8. I could use 2, because 2 divides 24 and 16. I could use 4, because 4 divides both 24 and 16. Or I could use 8, and they're all correct. So what I'll do is I'll make my parentheses. Since it's operation and subtraction, I put that down there. And then I figure what's a number that factors 24 and 16? Well, one number is 8. 8 times what's 24? 8 times 3 is 24. 8 times what is 16? 8 times 2x is 16x. I'm sorry. So that's those problems. Now your job is on your sheet of paper to go ahead and do the problems that are down there. I want you to do 6, 9, 11, 12, 13, 14, and 15. Okay, and then after you get that done, you can come up to Mr. Petterson and get another test to retake that. Thank you.